Yeah, Bam, good evening to everyone. Uh, as this is yet another case study on creep failure of low pressure turbine blades on an aircraft engine. Um, as we are seeing many case studies in the days when the week before, week before or month before. So this is another case study which is mainly deals about the creep failure. Uh, in previous videos also we have spoken about creep. But this here the creep failure occurs at a turbine blade of an aircraft engine. As its name says that creep failure. As we all know, creep failure means here the failure happens. The creep failure usually happens at high temperature when the load is acting. So we can say that when the load is acting, high load is acting, and at the high temperature we can exercise the creep failure, right? Or we can expect the creep failure. So this is the turbine blade, which is made up of material, and we will speak it about later. See, these are the turbine plates, and a small crack has been formed. So as in every state, in every sector of an or every step of a case study, we will have some analysis. So before going it, we have some operation characteristics for this blade. One is this operation environment. It is a high temperature, fuel and air contamination, soil particles, etc. As we all know, this particular blade is operated in the aircraft engine, and this you can see the turbine where this aircraft these blades are fixed. You can see the operation temperature may be at high temperature because of the engine is running and fuel and air contaminations happens, and also some solid particles can enter. Second one is high mechanical and thermal stress. This high mechanical stress is due to centrifugal force and vibration, and the thermal stress is due to the thermal gradients which happens during the flight. This type of damages can be divided into two types, that is external and internal surface external and surface damages. Surface damages mainly causes due to corrosion, oxidation, crack formation, erosion and foreign object damages. The internal is due to phase aging, grain growth, grain boundary, creep voids, and maybe due to brittle phase formations, and this are some of the factors mainly helps to form the failure. As coming to the next in this more add to that, we have some deteriorations in the individual blade differs, that is total service time and the operation history. As you can see, there will be number of startups and shutdowns and trips for a particular aircraft engines that happens, and moreover you can see the total service time for a particular engine, and some engine operation conditions, but that is it is in operation. Next one is in operation conditions, like next one is the manufacturing part. See, the blade is used as a high strength nickel based superalloys, as the name superalloys indicates that it is used in high temperature, and you can see the crack is initiated here. This in these parts are observed, and these parts are as in these parts are observed. In the visual inspection, you can see this is the leading edge and it is a trailing edge. You can see in here the blades are failed, and it is shattered like this, right? This is the fracture surface, and it is broken into many pieces. In the visual inspections, you can see there are some damage regions that are found, and here can see there are some grinding marks and rubbing marks here and there, right? And for this chemical composition for this OE manufacturing, you can see it is this UDMAT 500. It is clearly matching with the base structure, but even though it is acting at high temperature, you can see a failure. So in this you can see the blades which is unfailed blade or failed blade or new blade. You can see the hardness is more or less same, so you can clearly take in consideration that this blade is not failed due to the mechanical strength. And you can see these are some primary carbides that has formed, revealing carbides, and after this higher magnification after polishing the failed blades. So here you can see some intergranular corrosions. See, these are some intergranular cracks which is due to the corrosion, and the region B you can see So no cracks are in the blades. Right here, this it is seen in the two ways. See, you can see some cracks it is formed, and taking to that, you can see some neighboring blades also. This is the crack formation, and it is marked in this box area, right? And this these are semi images where we have magnified up to 1 lakh x, and it is so we can see some secondary carbon particles which is formed, and it is easily revealed in the semi microstructure. And here you can see there are some primary gamma structures and gamma fine grains, and there are some carbates as it is featured in the previous states. As here you can see in the fractalography, you can see this. These are the phases where the pedic facets are formed, and these are the grain dropped areas. So this is magnified here, and these are the grain dropped areas. So this area is which is boxed over here. It is seen in this area. Right? So here from a low magnification, higher magnification, you can see some coarse grain striations where the crack has been propagated. And in this we can say the surface of the blade is unprotected because it is not coated properly, and the temperatures around 750 to 800 degrees Celsius. And the microstructure includes says the gamma prime size, and it is failed at the adjacent to the unfailed area or unused blades. So at the region C, you can see the cracks is up to 2 mm depth, and it is where it is confirmed at the region C. So here it is sees that the relatively high strains and intermediate temperature promotes the wedge cracks, and the strain rate are the dominant factor for this fracture, fracture mode. And you can say, and the final conclusion, you can see this blade is primarily failed due to the creep cracks at region C, and there is no microstructural degradations of high temperature which is observed because it is already superlight. So there won't be some microstructural degradation, and it is crude strength and the hardness is failed or closer to the unused blade, so there is no degradation in the strength of the material. The main thing is that it is due to creep. The creep occurs only at the high temperature. Thank you. That's all for today. Have a nice day.